Good day, everybody, and thank you for joining us. My name is Abdurrashid Kuti, and today we will discuss securing modern apps from code to cloud. Now, let's start by explaining what this means in simple terms. An an application is any software that people use. Yeah. For example, a banking app, a a payment app, yeah, or a platform, a website. Now these apps are no longer as as simple as they used to be in the past. They are now built using many parts that connect together, and this part might be code that is written by its developers. It might also be external tools and cloud platforms where the app runs. Now, because everything is connected, if one part fails, the whole system can be at risk. So in this session, I will help you understand where risk comes from in modern apps, how attackers also take advantage of those risks. So let me walk you through what we will cover. Yeah, first we will talk about the threat landscape, and this means understanding where attackers come from and how they think. Next, we will look at secure SDLC, which means Software Development Lifecycle. And this is the idea of adding security into every step of building an app. Then we will discuss security prac- practices. And this means how we write safe codes, how we test apps, and how we secure our cloud systems too. After that, we will review a real case called Log4Shell, which shows how a small issue can affect many systems worldwide. To understand security, we must first understand how modern apps are built. In the past, apps were simple. They ran on one server and had limited fee features. Today, apps are built in a more complex way. They include a APIs, and A APIs allow different systems to talk to each other. For example, a banking app may use an API to connect to a payment system. Next, we have microservices. Instead of one large system, apps are broken down into smaller parts, and each part would handle a specific function. Next, we have cloud systems. Apps are now hosted on cloud plat platforms instead of local servers, and this is because of the cost and uptime. Now, for third-party tools, devs use ex external libraries and tools to build faster. While this might improve speed and flexibility, they also have a risk. Think of it in this way. If you have a house with one door, it is easier to secure. If you have many doors and windows, it becomes harder to protect. Now let's look at the common attack types. First, we have injection a- a- attacks. And in this one, attackers may send harmful inputs into the system. So what this means is they might enter code into a, a form so that when it gets to the database is going to read that as a code and act on it. Next, we have misconfigurations. And here it is just like the name is. This is where our systems are not set up in a proper way. For instance, data might be left open to the public. Next, we have broken authentication. Then we also have supply chain attacks. In this case, attackers might target third-party tools that is used by the app. And the key thing that we should notice, every connection in your system can become a point of attack. Now let's look at a real world thing called log4 shell. This broke the entire world for a few weeks, for months. Yeah. So this is one of the most serious things that has happened in recent years. Log4j is a tool used in many apps to record system activity. It helps devs to track what is happening inside the systems. The problem was this: that tool, it accepted the input of users and it treated it as code. So, and what this meant is that this allowed attackers to run commands remotely. Now, why was this so bad? Because many apps all over the world used this same tool, like a lot of them, from phones to cars to name it, it was being used round the world. And devs did not know it was a part of it because of what I had said before. It was a dependency tied to one that they had no idea that they were making use of that. And that issue spread very quickly. In such a short time, millions of systems were exposed. Attackers began to exploit this almost immediately. The key lesson here, it's important because when you use external tools, you need to know that you also take on their risks. And this is called dependency risk. Even if you even if your own code is as tight as can be and is secure, a weak dependency can still create a major issue. Now, next, let's talk about secure SDLC. And like I had said before, SDLC means Software Development Life Cycle, and this is the process of building software. It goes from planning to design to coding or development, like we call it, to testing to deployment. Now, secure SDLC means that you add security into each and every one of these stages that you can see on the screen. And instead of waiting until the very end, it's best we think about security from the onset. And these are the two key things that we should know. For example, yeah, it is easier to fix a problem during design or coding or testing than after the app has gone live. Then we also need to make use of DevSecOps, and this means the developer, security team, and ops all work together. Security becomes part of the daily work, not a separate step. And the key thing that we need to know from this is fixing pro problems early saves time, money, as well as the efforts. Now let's talk about security in design. Security begins at the design stage, yeah, because before we write code, we need to ask the important things like what are we protecting? For example, it can be user data, can be financial data, and we need to ask what can go wrong because we now know what we are trying to protect here. And the instances here can be data leaks or unauthorized use. Now, the next thing that we now ask is how do we prevent it? And all of this is a process called threat modeling. Now let's look at two im- important things. First is least privilege. First, we need to give users only the access that they need. Nothing more, nothing less. Give them access to only what it is that they need to use for work. Because then, for instance, a user that is only meant to view a type of data should not be able to change it or delete it. Then next is defense in depth, and this means that we need to have multiple layers of security in case if one fails, the other might still provide some sort of protection. Now let's talk about coding. Most security problems start at this stage, the stage of coding. Yeah. So, and because of this, developers must follow safe practices. The first that they should do is input validation. Now, there always needs to be a check when a user does an input into something like a form, yeah, and this is for us to make sure that what the user has done is very safe. Next is output and coding, and this is to make sure that the data is safe before it is shown on the screen. Next is secure authentication. We should always make use of passwords that are strong, as well as extra checks like MFA. Then next is no hard-coded secrets. Store keys in vaults, never inside code or config files. And next is only use tools that are trusted and well known and maintained for when we can find bugs. So now let's talk about dependency and supply chain. Most apps, in fact, at this point in time, I'll say all apps depend on many external tools. And these tools help devs to build faster, but they also bring risks. Yeah. And it might be things like malicious code or packages that are fake. And how do we have any form of way to manage this? First is to ensure that we scan our dependencies. all often. Next is we always need to track the versions that we make use of to know when it has any major change. Then next is for us to have our updates every single time that an update comes in. So next, let's talk about security testing, yeah, because this is what helps us find our issues before the bad guys do. And there are different types. The first is SAST, or static app security testing. Now this checks code before the app runs, yeah, before we go live. This checks codes to be sure that we have written in a safe way that would not um, ex expose us to any form of attack. Next is DAST. And now this tests the app while the app has gone live, while it is running. Next is IAST. And this is the combination of both. Yeah, you scan before and after it has gone live. Then the last one, which most of us know, is pen testing. Yeah. So what this is that we as the good guys, or as the blue team, or the red team. Yeah, we test the system in such a way that we act like we are the bad guys, and in such a case we can find things that need to be fixed, like a logic flaw or a different type of attack chain. Now let's talk about cloud systems and the risk that comes with it. But most of them are mistakes that are as simple because they are majorly called misconfigurations. Yeah. First is open storage, then weak access control, then a lack of encryption for data at rest and data in transit. And the last is a lack of monitoring. Yes. So now one major thing that we need to talk on here is DevSecOps. And I will break this word into three parts in such a way that it is going to be easy to understand. Dev means development, and this is writing the code. Sec means security, and this is protecting the system. Ops means operations, running and managing the system. So DevSecOps means security is added into development and operations from the start and not at the end. Now, why is DevSecOps important? It is important because in many places, security is treated as a final step, and this means that devs will build the app first, then security teams will check it late, later. And what this means is that issues are found too late. Fixing them becomes expensive, and some problems are completely missed. Now, DevSecOps solves this. It makes security a part of the daily workflow. And what DevSecOps looks like in practice can be, let's take an instance where a dev would write new code, and instead of waiting for security to review the code at a later time, The code is scanned immediately. Tools check for issues that are known, and any problem is flagged early, there and then, and it is solved before going to the next stage. Now let's talk about the key things that is done in DevSecOps. The first is code scanning. And like I had said, we have SAST and we have DAST. And tools we have tools that will check the code for mistakes that are common and happen all the time. Next is container inspection or dependency scan. Yeah. So these tools will check the the external things that is used by this app. Is the library safe? Does it have any kind of known issues? Yeah. And how do we fix it or stop it? Next is secret detect detection. Yeah. Tools check for for secrets that are exposed. Things like passwords, to or tokens that should never be inside code. Then lastly is continuous monitoring. So and why all of this matters is that this runs every time the code is updated, and this is to reduce any form of human error. So on the next slide, we will take a look at a real world issue, which is an API data leak. Yeah. Now, what is an API? Like I had said, an API allows different systems to talk to one another. A mobile app may use API to get user data. And in this case, what went wrong was the API had zero authentication. So this means that anybody could access it. And let me explain what that means. Normally, systems should check who are you before giving you any form of access. But in this case, no login was required and no identity was shown. So how did the attack now come to be? An attacker scanned the internet and found the API. And this is easy because they make use of tools that are automated. And once they found it, they sent requests to the API, and the API it gave a response with data that is real. And these are things like account numbers and user details. And the impact of this meant that over 10,000 records were exposed, and a lot of sensitive data was leaked. And this issue, despite this, it was not known for weeks. So, what are the key takeaways that we need to have based on what we have all said? The thing is, the first is security must be built in. It should not be added at a later time. It must be a part of the SDLC throughout all the stages, from design to dev to testing and to deployment. If you wait until the end, it is too late. Next, developers are the first line of defense, and this is because they write the code. So they are the best ones to prevent this kind of issues. If the code is secure, many issues would never have been in place. Next is automation is essential. Manual work is never enough. People can forget or make mistakes. Automation helps by doing checks all of the time and catching issues early. And lastly is monitoring is non-negotiable. Even after your app has been tested and deployed, there is still risk. So systems must be monitored, and this helps to detect attacks at an early stage and to respond quickly. And it also helps to reduce your damage. So thank you very, very much, and do have a wonderful day. And please let me know if you have any form of questions. Thank you so much, team. Bye.